Equilibrium concentrations, part 1. I'm Mr. B. Given this equation where H2 plus I2 is in equilibrium with 2HI, calculate all three equilibrium concentrations when the initial concentration of H2 is equal to the initial concentration of I2, which is equal to 0.200 molar, and a Kc value of 64.0. Begin by drawing an icebox. An icebox allows the data to be organized in a logical fashion, where the term ICE are the first initials of initial, change, and equilibrium concentrations. Now we insert the initial concentrations of all species into the icebox, where the initial concentration of both H2 and I2 are 0.200 molar, and the initial concentration of HI is 0.0 molar. Now use X's to represent the change in concentration. The negative sign means that the concentration of the reactants are going down. The plus sign means that the concentration of the products will increase. To write the equilibrium conditions, simply combine the initial concentrations and the change. Now we're ready to place the values into the equilibrium expression, where Kc or Keq is equal to the concentration of the products raised to the x power divided by the concentration of the reactants raised to the y power, where x and y represent the coefficients in the balanced chemical equation. For this particular reaction, Kc or Keq is equal to the concentration of Hi squared divided by the concentration of H2 times the concentration of I2. Now place the value of Kc into the equilibrium expression, where Kc is equal to 64.0. So 64.0 is equal to the concentration of Hi squared divided by the concentration of H2 times the concentration of I2. Inserting the values from the ICE table at equilibrium yields the following. 2x squared is divided by 0.200 minus x times 0.200 minus x. This simplifies to 2x squared divided by 0.200 minus x squared. This represents a perfect square, so we may now take the square root of both sides of the expression. The square root of 64 is equal to the square root of 2x squared divided by 0.200 minus x squared. This simplifies to 8 is equal to 2x divided by 0.200 minus x. Multiplying through by 0.200 minus x yields the following. 8 times 0.200 minus x is equal to 2x. Multiplying through by 8 yields the following. 1.6 minus 8x is equal to 2x. Now add 8x to both sides of the expression. 1.6 is equal to 10x. And to solve for x, we simply divide through by 10. So x is equal to 0.16 molar. This information may now be used to determine the true equilibrium concentrations. The concentration of H2 is equal to 0.200 minus x, or 0.200 minus 0.160, which is equal to 0.040 molar. Likewise, the concentration of I2 is equal to 0.200 minus x, which is equal to 0.200 minus 0.160, which is equal to 0.040 molar. the concentration of HI is equal to 2x. So 2 times 0.160 is equal to 0.320 molar. We've now calculated all three equilibrium concentrations for the reaction. This concludes my lesson on equilibrium concentrations, part 1. I'm Mr. B.